Enterprises today don't just need data platforms. They need intelligence in motion. Flex83 unifies data, assets, AI, and operations into one living ecosystem, turning real-time signals into real-world outcomes. We start with workspace management. Each workspace is an isolated environment. Data and configurations stay independent, so teams don't collide. You can create a new workspace anytime and switch between workspaces to continue your data handler journey. Next is IAM, Users and Access Control. You can define admin roles or create custom roles with limited permissions, and audit logs capture every important action for traceability. So governance is built in from day one. Finally, disk usage gives you visibility across platform storage. Now that the environment is governed, let's secure external access and extensibility. API keys secure access for external applications calling your data, or APIs. Every external request includes a valid key. You'll typically create server keys and browser keys. Server keys support backend and server-to-server integrations. Browser keys support client-side apps and can be restricted using a domain whitelist, so only approved domains can call the platform. In settings, you can also apply custom branding for the platform. That includes updating the theme palette and visual styling. You can adjust typography and icon styles as well. You can even customize the login experience. For example, background images, placement, and visual layout. Flex83 also supports internationalization. You can set a default language for the platform and switch to other supported languages as needed. Next is Identity Provider Management for authentication. Multiple providers are supported. One may be enabled by default, but you can configure any provider your enterprise requires. And this is the Artifact Manager, where extensibility becomes real. Bring your own connectors to add integrations, and bring your own transforms to standardize custom logic. Now we move into the Knowledge Hub, where Flex83 enables RAG-based knowledge systems. This allows enterprises to ground AI responses on their own operational data. The first step is creating a RAG model. You start by selecting the provider choosing the model and securely configuring the API credentials. Once created, the model becomes available in an active state. Next, you define the knowledge data sources. Flex83 supports two types: action data sources, where files or operational artifacts can be uploaded, and flex data sources, directly connected to platform data. For example, structured tables from Iceberg or warehouse layers. Multiple data sources can be registered into the same knowledge system. Once sources are ready, you create a knowledge context. This defines the domain the AI will reason over. You can attach multiple data sources, map them to the RAG model, and configure the embedding model used for semantic understanding. The next step is training the context. Flex83 processes and embeds the data, making the knowledge context active and ready for use. Now users can ask questions in natural language and receive grounded answers based on enterprise knowledge. Now we enter the real-world flow, Flex IoT Hub. We begin with asset types. Create an asset type to define the model using a guided setup. You'll configure the structure in the UI and provide the required details. This defines how the asset behaves and what it captures. You can also upload your ontology to standardize the model, then review and refine, confirm the details, and finalize the definition. This becomes the foundation for onboarding real devices, and the platform exposes the configuration you need. Once ready, submit the asset type. You now have a structured type ready for deployment with built-in strong configuration options. Now we create an asset. You get a guided interface to enter device identity and metadata. Select the asset type you just created. Add description and location, including map-based placement. On creation, the platform generates device credentials. You can download or copy them and use them for MQTT connectivity. This makes onboarding fast and consistent. Once connected, you see device status immediately online or offline in real time. This is built-in operational visibility. Now let's follow the data. In the connectivity matrix, you see assets, messages received, and bytes received across the fleet. This is your live proof of connection, and you can pause pipelines when needed. Plus, MQTT publish samples help validate ingestion quickly. Integrations are how you connect external sources into Flex83. They define the data pipelines that connect any external system to the platform. This is where ingestion begins. You configure the source and ingest into Flex83. You'll find many plugins available out of the box. If you need something unique, you can bring your own connector, and it appears as a plugin. Now we will configure an available connector. Connector setup is simple, only what the source needs. For example, URL, client credentials, and connection settings. Then you define the Kafka topic. That topic becomes the stream backbone for everything downstream. Converters define the ingestion format based on your pipeline needs. Multiple formats are supported. Pick what matches your schema, then select it and continue. Transforms let you modify data before it lands. For example, mask sensitive fields or standardize values. It runs before ingestion completes. So sensitive data stays protected even before storage. Likewise, we can create a connectivity to an external data source and see the flow. Now let's look at streams. Data streams list the Kafka topics created from integrations. Select a stream and you see operational details, partitions, replication, messages received, and offsets. You also get monitoring information like byte and message rates for observability. Inspect schemas and validate structure. Monitoring graphs show throughput, and you can inspect messages directly on the topic. This confirms live data moving from source to platform. After ingestion, we store data for long-term analytics and operations. Streams have retention often limited by default. Retention can be configured, but durable stores are the real destination. Flex83 supports multiple ingestion paths. Stream ingestion writes to stream tables. Select the stream, define table and primary keys, and you're ready. Cube ingestion writes to analytics databases for dashboards and operational analytics. Lake ingestion writes to warehouse storage for reporting and historical analysis. Choose stream, scale workers based on volume. Then monitor the flow. You see messages received and processing lag. Here, lag is 0. Data is flowing cleanly. Outbound ingestion pushes data back out to systems like databases or HTTP targets. Plugins make it flexible and extensible for your ecosystem. Flink apps let you process streaming data in real time. Use them for validation and transformations. You have two approaches, jar-based or SQL-based. Choose based on the complexity you need. With the help of this, we can create a custom Flink job and upload to the platform. For jar-based jobs, select the source stream, define the output stream, and set job parameters. Submit, and the job runs continuously. SQL-based jobs are ideal for quick transformations. For example, aggregations and filters. Select source stream, write SQL, and publish to an output stream. Batch jobs manage scheduled loads into analytical systems. You can run different batch patterns like FlexLake to FlexCube. Select a source, set destination and timestamp, and preview before creating. Once created, jobs appear in the list with source, destination, and schedule. For example, runs every 15 minutes. Job schedules give you execution history. You get a task breakdown per run and full visibility into each task. Logs show exactly what happened, so operations stay accountable. For large-scale data transformations, use Spark apps. They support big compute workloads. To start with this, first upload the jar. Your code defines the transformation, and the platform runs it as a managed job. To submit a Spark job, set name and description. Core details are pre-filled, then you configure resources. Use presets for small or large jobs. Also, if you know your configurations, you can add these manually. You can also see the various job performances from here, including what were the queries that ran. Users can create and save queries for reuse across platform stores. The data catalog adds operational visibility. You see scale indicators like row counts and size, so teams can validate data and usage quickly. Now we query the data across stores. The SQL editor runs queries and validates results. FlexStream supports live and near real-time queries. Use it for the newest data. FlexCube supports fast operational queries, ideal for dashboards and quick analysis. And FlexLake handles large historical volume for deeper and more complex analysis. Next, we bring AI into the workflow. Let's begin the machine learning walkthrough inside Flex83. The prerequisite is data availability within FlexLake, an open table format built on Apache Iceberg. This serves as the enterprise data lakehouse, housing operational, transactional, and IoT datasets. From here, teams identify datasets relevant for machine learning use cases, such as customer analytics, transactions, or IoT sensor telemetry. Each dataset contains temporal, categorical, and operational attributes, including potential target variables for prediction. For example, anomaly detection in sensor data. Model creation begins in ML Studio, where FlexLake tables are directly accessible. The platform guides users through a step-by-step workflow, starting with source selection, followed by profiling, data cleaning, feature engineering, and model training. During profiling, Flex83 scans dataset structure and quality. It evaluates volume, schema, and completeness, including null values, duplicates, and distribution patterns, providing a statistical foundation before modeling begins. Column-level analysis surfaces quality gaps, such as missing values or skewed distributions. These insights drive cleansing strategies, ensuring reliable model performance. Smart recommendations accelerate preparation. Flex83 highlights transformation actions, such as encoding categorical fields or removing non-contributing attributes. For example, device IDs or timestamps that don't influence anomaly prediction. Users can apply filtering and transformation rules, including threshold filters, column drops, and identity removal, ensuring generalized model learning rather than device-specific bias. Null handling strategies such as mean imputation prepare datasets for feature engineering, while outliers can be clipped or normalized. A preview validates transformed data before committing changes. The clean dataset is versioned and stored for downstream modeling. Next comes feature engineering, where attributes are transformed for learning. Flex83 recommends optimal treatments, such as normalization or encoding. Previewing engineered data confirms transformation outputs. Categorical fields become encoded ready for algorithm consumption. Feature datasets are then materialized, with governed naming and lineage, ensuring reproducibility across experiments. With data ready, model selection begins. Target variables are defined and features finalized. For anomaly detection, classification models apply. Training configuration is auto-prepared, including train test splits, hyperparameters, and experiment tracking. Model training is then executed. Trained models are logged to the registry, connected to ML flow governance, ensuring lifecycle traceability. Model accuracy and performance metrics are instantly available, including precision and recall. Visualization tools explain model behavior, highlighting feature contribution and prediction influence. Confusion matrices, ROC curves. All trained models are centrally cataloged with governed version control. These models can now power predictions across streaming pipelines or batch datasets using simple prediction APIs, embedding AI directly into operations. Meet Helix, Flex83 AI Genie, built directly into the platform. It's an AI-powered operational data assistant designed to help users move faster. It works across integrations, data lakes, and IoT assets, and connects to dashboards and the asset experience. So instead of clicking through screens, you can ask in natural language. First, the Stream Assistant. It can inspect brokers, topics, and topic details. For example, check Kafka cluster health. The assistant returns health instantly. Next, the Integration Assistant. It discovers connectors and their state. You get an immediate summary and available actions. You can even pause a connector. The assistant validates state and executes the action securely. Then, the Lake Assistant, embedded into the SQL editor. It works directly over your data store. You can browse tables, view schema, and run queries without writing SQL. For example, browse the available tables, ask it to create a query, execute it, and review results with conversation history. So teams get answers faster with less friction. There's also an IoT hub assistant to check device types, device status, in controls. And inside the query experience, you can generate SQL. Open the helper, describe what you need, get generated SQL, and execute to see the output. Flex83 brings it all together. Governed workspaces, connected assets, extensible integrations, real-time and batch processing, self-serve discovery, and AI assistance, built into one operational platform.